Hey there, welcome back. We're going to learn how to solve exponential equations and inequalities. Those are our objectives. How do I solve an exponential equation? How do I solve an exponential inequality? And then third, we're going to learn how to write an equation if we're given 2 points on the exponential curve. So remember in lesson 1, we were given a graph and we could pull the points off. Well, now we're just going to be given the points and we're going to do all the work from that. Okay? An exponential equation, well, it's an equation. What does it mean to be an equation? Has to have an equal sign. Has to have an equal sign. And in this case, not only do we need an equal sign, but we need a variable exponent. So our variable has to be located in the exponent. Okay? So if we have an equation and our bases are the same, see how I have base 2 to the x equals base 2 to the 8th? Well, if the two bases are the same, then the exponents have to be equal. So we would set them equal to each other and solve. In this case, this is a very simple example, and I don't really have any solving to do because x just equals 8. Now, if the bases are not the same, and you guys, this happens a lot, and there are several techniques for solving, and some of them we won't get to till after the break. But for tonight's lesson, what we're going to do tomorrow in class, if the bases are not the same, then we're going to rewrite the bases in the same base. Okay, so for instance, here I have an equal sign and I have a variable in the exponent, but look at my bases. This one is a 2 and this one is a 16. They're not the same. So I'm going to rewrite 16 in terms of base 2, so it's 2 to the 4th. Now what I've done is I forced my bases to be the same, so that means my exponents have to be equal, and x has to equal 4. Couple things to remember: always take the larger base and rewrite it in terms of the smaller base. Sometimes you might have to do both sides, but always go down, never go up. Never try and take 2 to be 16. Always go the other way. And then we're going to talk about exponential inequalities. It's an inequality, and so with a variable exponent, and so we could have less than, equal to, greater than equal to. Okay? So here's kind of our main property. Equality property of exponential functions. If two exponential expressions are equal, and if the bases are equal, then the exponents must be equal too. So I'm trying to do this kind of in color here. My bases are 3. Okay, my bases are the same. I have an equal sign, so that means that my exponents have to be equal. And notice what I have here. 2x is equal to x plus 4. So now I'm going to solve for x. So I'm going to subtract x from both sides. This is minus x, and so I get x is equal to 4, and that's my solution. X is equal to 4. Okay. If the bases are not equal, as I've alluded to before, we're going to rewrite those bases to be the same. Okay. Sometimes you get away with just rewriting one, the larger one. Sometimes you have to rewrite them both in a smaller base. Okay. So if I'm given the example, and this is all worked out, so I'm going to just talk through it. 3 raised to the 6x is equal to 9 raised to the x minus 4. Okay. So notice how my base 3 over here does not match my base 9, does it? Okay, so what I'm going to do is I'm going to leave base 3 all alone, just going to leave it as it is, but I'm going to take 9 and rewrite it as 3 squared. Okay, so now I have a power raised to a power, so these two things are going to get multiplied together, and that I'm showing in my next step. So I have base 3 to the 6x is equal to 3 to the 2 times x minus 4. Right? Another way of writing that is 2x minus 8. So this is 2x minus 8. Okay? So if these two bases are the same, I have the 3 and the 3, and I have an equal sign, then this exponent has to equal this exponent. So 6x has to equal 2x minus 4. Okay? I'm going to solve it. I'm going to subtract 2x from both sides. I'm going to do it on top. Minus 2x minus 2x. So this gives me 4x is equal to negative 8. I'm going to divide by 4. And I get x is equal to negative 2. Just keep in mind that on some of these problems, many of them, you might have to reduce or rewrite the base on both sides, okay? So let's do several examples. I'm given the equation 5 raised to the 5x is equal to 125 raised to the x plus 2. My bases are not the same, so I'm going to rewrite 125 as 5 cubed. So I get 5 to the 5x. I'm going to erase that. It looks crumbly. 5 to the 5x is equal to 125 is 5 cubed, so that's 5 to the 3 times x plus 2, okay? Now I'm going to apply the power to the power, so I still have 5 to the 5x equals 5 to the 3x plus 6. Now my bases are alike. I have an equal sign, so that means my powers must be equal. So 5x has to equal 3x plus 6. I'm going to subtract 3x from both sides. Minus 3x gives me 2x is equal to 6. And x is equal to 3. All right, so that would be my solution. Why don't you try this number 2 in your video equation? So the bases are not the same, so rewrite. All right, so I have 4 to the 2x minus 1 equals 4 cubed. Now my bases are the same, and I have an equal sign. So 2x minus 1 has to equal 3. 2x minus 1 has to equal 3. So 2x has to equal 4. So x has to equal 2. Make sense? Okay. Now we're going to talk about the inequality property of exponential functions, and it follows the same line of thinking. If I have an inequality, doesn't matter what direction my inequality is going, if my bases are the same, then the inequality has to apply to the relationship of the exponents too. So notice here I have 3, base 3, base 3 with an inequality. All right, so that means that 2x has to be less than x plus 4. I subtract x from both sides, and that means x has to be less than 4. If we wanted to write it in interval notation, that would be negative infinity to 4 parentheses. If the bases are not the same, we're going to rewrite the expression with the same basis. So this is the same equation. I just put an equality sign with it. All right. So what I did, my 3 and my 9 were different. So I brought my 9 down and I rewrote it as 3 squared. Then I applied my power to a power and multiplied these two exponents together. But notice what I did instead of an equal sign, because this is greater than, that means that 6x has to be greater than 2x minus 4. So that means I subtract 2x from both sides. 4x has to be greater than negative 8. X has to be greater than negative 2. All right, so I'm going to do the first one. And this is an example of where I have to rewrite both bases. So notice that I have 16 to the 2x minus 3 is less than 8. So what I'm going to do, because I can't rewrite base 16 in terms of 8, and I know what we all want to. We all want to say it's 8 times 8, but 8 times 8 is 64, not 16. So I'm going to take both of these bases and I'm going to write them in terms of base 2. 16 is 2 to the 4th. See what I did there? And then 8 is 2 cubed. Okay? Now I'm going to apply my power to a power property, and so I get 2 to the 4 times 2x is 8x minus 12 is less than 2 cubed. So now I'm in the same base, 2 and 2. So that means that my exponents have to have the same inequality. So I have 8x minus 12 has to be less than 3. So now I'm going to solve. 8x is less than 15 because I added 12 to both sides. Now I'm going to divide by 8. So x is less than 15 over 8. Okay? All right. Why don't you try number 2 on this slide and see what you can do. So here's a little bitty hint here. Oh no, you don't need a hint for this one. You go ahead. Try this one. All right, welcome back. This is base 2, so I'm going to try and rewrite 32 as 2 raised to a power. So I have 2 to the x plus 2 is greater than 2 to the 5th times negative 1. All right, so now I have a power to a power. I'm going to multiply them. So I get 2 to the x plus 2 is greater than 2 to the negative 5. My bases are the same, so that means my exponents have to follow the same inequality. So that means x plus 2 has to be greater than negative 5, and that means x has to be greater than negative 7. Okay? All right, now we're going to do writing of equations. So write an equation of the exponential function going through the points 0, 12, and 350. It's the same thing that we did before, only we're just given the points and not a graph. So we're going to use the y-intercept 0, 12 to find a. So I'm going to plug in, this is my x, this is my y, and then I'm going to solve for a. So I get 12 is equal to a times b to the 0. B to the 0, we learned that. That's going to be 1. Okay, so that means a equals 12. Now I'm going to plug in this a. I'm going to plug in a equals 12. And then I'm going to use this other point, which is 350 for my x and my y. So I get 50 is equal to 12b cubed. Now I'm going to divide both sides by 12, and I get 50 over 12 is equal to b cubed. And then I'm going to take the cube root of both sides, and it's going to give me 1.6091. That's what b is going to equal. b always has to be positive. So now I'm going to write my equation. Y equals a is 12, b is 1.6091 raised to the x. Okay, notice that I started with this formula. We're not going to do any shifts. We're just going to do stretches or compressions. Okay, last one. I'm pretty sure this is the last one. Yep, it is. So notice that this one doesn't go through 0, the y-intercept, so we're going to approach it a little bit differently. So pay attention to what I'm doing here. So I'm writing the formula, and I'm going to take and I'm going to plug in the first point, okay? So I get 20 is equal to a times b to the first. So notice that I can't eliminate b, so what I'm going to do is I'm going to divide both sides by b so that a is solved for. So I get a is equal to 20 over b. Okay? I'm going to do the exact same thing for the second point, and I'm going to get 80 equals a over b cubed. So then I get a is equal to 80 over b cubed. All right, so notice that I have a equals and a equals. Well, remember the transitive property? Okay, so what we're going to do is we're going to set these two equal to each other. So I get 20 over b is equal to 80 over b cubed. Right? We're going to cross multiply. So I get 20. Hate it when it does that. So I get 20b cubed equals 80b. I'm going to divide both sides by b. So I get 20b squared equals 80. Now I'm going to divide both sides by 20. And I get b squared is equal to 4. So b is equal to 2. It would be plus or minus 2, but we know that b cannot be a negative number. All right. So now I know what b is. So now I'm going to plug it into one of these two equations. I'm going to pick the easier. So a has to equal 20 over b, but b is 2, so a equals 10. So I get y equals a, which is 10, base b, which is 2, to the x. Sorry. This is our, sorry. This is our assignment for tomorrow. So I will talk to you and see you tomorrow.